Hey guys, and welcome to 2.5. In this lesson, we're going to be talking about transformations of functions. All right, and so while you can do this on the graph itself, which we'll look at a little later, we can do most of this algebraically. And so first off, let's get started with talking about this stuff up here. All right, you have this basic graph in form of most parent functions. This encompasses most parent functions, and it is y equals a x minus h in parentheses raised to the nth power plus k. All right, the nth power, it could be the x minus h doesn't change, but the nth power, you could be talking about a square, a cube, a fourth. You could be talking a half, which means a square root. Instead of an n, you could also have absolute values instead of x minus h. All of this doesn't change. But a, if it's positive, great. Then the graph will act like normal. But if it's negative, that means it's going to reflect over the x-axis. So it's going to reflect down. So it's going to do something like that. Okay, and then if it's between 0 and 1, then it's a vertical shrink. So if it's a fraction or a decimal between 0 and 1, then it is a vertical shrink. And again, if it transitions from a positive number to a negative number, the negative doesn't affect the stretch or shrink of the graph. It simply tells you whether it's opening up or down. Okay, and then if the absolute value of a is greater than 1, it's a vertical stretch by whatever that number is. Okay, h is a horizontal shift and k is a vertical shift. One key note that we want to make about that is notice the signs on h and k. H is the horizontal shift, but it has minus h, and then k is the vertical shift, but it says plus k. Because it says plus k, you're going to do exactly what you think you're going to do. A positive number is going to be an upward movement, and a negative is going to be a downward movement. Right? It's the exact opposite with h because of that minus sign. If it's minus a number, then it's going to be a rightward movement, and if it's plus a number, it's going to be a leftward movement. Right? So anytime you see this minus h, you got to think the opposite. Another way I like to think about it is if it is inside the function, like it is here, which is h is always inside the function, k is always outside the function. If it's inside the function, then it's doing the opposite of what you think it's going to do. And if it's outside the function, it's doing exactly what you think it's going to do. So keep that in mind as we go along. All right, so all these problems, you're trying to figure out, all right, f is my parent function, g of x is the transformation. All right, what did you do between f and g to go from one to the other? Okay, so here on number 1, all I did was I simply took the original graph and I moved up 3. I moved up 3. So you can write up or you can do a little arrow. Either is fine. I would typically go with the arrow, but just so you know what you're talking about. All right, number 2, how did I go from f to g? Well, f of x is my original. So for g of x, I had a plus 2 on the inside and a plus 2 on the outside. Well, remember what I said. If you have a plus 2 inside the function, it's going to do the opposite of what you think you're going to do. So that's going to be a leftward movement of 2 because of that plus 2 on the inside, and then the plus 2 on the outside is going to be an up 2. Okay, number 3, you have f of x plus 4. All right, so the x plus 4 is inside the function. All right, so that's going to be left 4. All right, this is really as easy as that, guys. On number 4, it's 2 times the original function. Okay, because that is bigger than 1. All right, it's going to be a vertical stretch by a factor of 2. That's how that goes. All right, number 5, we're going to start picking up the pace and getting a little more complicated, adding more pieces to it. All right, but each one, no matter how many pieces I got going on, whether it's a, h, k, a is negative, whatever, like you just do one at a time. You start labeling them off one at a time. All right, so we're going to move from left to right. That 2, that's going to be a vertical stretch by a factor of 2, and it's going to be left 4 and up 4. All right, 6. All right, you have a negative out front. Okay, so that negative is going to reflect it over the x-axis, and then that minus 4, remember it's inside, so it's going to do the opposite of what you think it's going to do, so that's going to be a right 4. Okay. All right, 7. All right, this time the number out front that's being multiplied to the function is less than 1 but greater than 0. Okay, so that's going to be a vertical shrink by 1/2, and left 1 and up 2. All right, on number 8, you're not exactly, they tell you what f of x is instead of just saying, oh, this is how it applies it. And so you're supposed to read f of x as the parent function, and then g of x is how you changed it. Okay, so on 8, it says f of x is x squared. Okay, so I know what I'm working with. I know where I'm starting. G of x is negative x plus 3 all squared. Okay, so I have the negative on the outside that's going to reflect it across over the x, and then you have the 3 on the inside, but remember it's plus 3. The basic form is minus h, so that's going to be a negative 3, which means I'm going left 3. Okay, and the squared is just a squared. That's from my original, so I don't do anything with that. So this is what we got. All right, so we're going to reflect over the x-axis, and we're going to go left 3 to go from f to g on number 8. Number 9, again, we're starting with x squared, and then we have negative 3 on the outside, x minus 6 on the inside, and plus 4 on the back end. Okay, so that negative is going to reflect it over the x-axis. The 3 is going to be a vertical stretch by a factor of 3. The 6 is going to be right 6 because it's x minus 6, and then the plus 4 is going to be up 4. All right, so that's what all your pieces are doing. Again, you do it from left to right, chipping away one step at a time. All right, number 10, you have f of x is the square root of x. All right, on number 10, you have f of x is the square root of x. And then on the g of x, you have minus 5 on the inside of the function and plus 3 on the outside. So again, it doesn't matter if I'm dealing with absolute values or if I'm dealing with parentheses with the exponent or without an exponent, right? Whatever that grouping symbol happens to be, we're talking the difference between inside the function or outside the function. And if you think about it in those terms, h and k never change, okay? So here, the minus 5 is going to be a shift right 5 units, and then the plus 3 on the outside is going to be up 3. So you're going right 5 and up 3. All right, so that's the basics of transformations. All right, I hope you got something out of this. And if you have any questions, please reach out, and I'll see you in the next video.